Okay, let's talk about this segment 3 problem. This problem simply asks us that in programming terms, if we talk about this problem gives us an array 10, 12, 15, let's say 16, 17, 200, and 132. Now, this problem says that we have to make sure that every triplet, every three numbers which are there together, their sum should be divisible by 3. The first triplet, second triplet, third triplet, fourth, and fifth. And in order to make their sum, every triplet sum to be divisible by 3, we can add something to any of the numbers. And the question asks us, like, what is the minimum number of additions or minimum additions you will have to do in order to make sure that every triplet is having a sum divisible by 3. Now, if we think about this, if I have three choices to begin with. Imagine if first three triplet sum is not divisible by 3, then what eventually will happen? Let's say first three numbers are A, B, and C. In that, if the sum is not divisible by 3, I may add something here, or I may add something here, or I may add something here. At least one of these numbers have to be added something. And now that something that we have to add is, there are three possibilities. Let's say sum is already divisible by 3. Let's say A plus B plus C is already divisible by 3. If that be the case, then our addition value has to be 0. Second option is this divisibility gives us remainder of 1. If that be the case, if remainder is 1, then of course we have to add somewhere the number 2, because if remainder is 1, that means 2 more is missing. For example, if you think 7 mod 3 is 1, so remainder is 1. So in 7, what do you add to make it divisible by 3? Of course, we'll have to add 2 so that this remainder plus 2 becomes 3. So this is second case. Third case is if the mod of these three numbers is 2, then of course we'll have to add 1 to any number. Now, which number we will add is what we will think about, we'll talk about. But we have three choices to make the first sum to be divisible by 3. Now, out of these three choices, think about it. We can choose to go with greedily, we can choose to go and add the number here. My first option is, I will say once such situation happens, I will choose to add to A. Then you will look at next triplet. There, if the sum is not divisible, you will go and add to B. But now, if you add to B, there is a problem. And the problem is, if you modify B, then sum of A, B, and C is not going to be divisible by 3, because this will modify our previous sum itself to be not divisible by 3. So this has an issue. So it is, if we have modified A, it is always advisable that we do not modify B, do not modify C. That means next modification that we are performing should be happening from D onwards, so that we don't touch this sum at all. And out of this also, if you go with the next three numbers, then you can modify. Yeah, so now this may become cumbersome, may become problematic to know like which values to add, which values to. If I modify A, then I can kind of keep this isolated, A isolated. But there may be some answers which will require us to modify B rather than A, because we are trying to minimize the additions that we are doing. So I can think of some test cases where B needs to modify. I can think of some test cases where C needs to be modified. So ideally A, B, or C, any one of them may need to be modified. And the moment we modify, let's say C, then the effect of C has to be cascaded to rest of the array also. So eventually, like if we have to think of how do we solve this problem, we can think of like what are the modifications that are possible to A. Of course, we may add 0, or we may add 1, or we may add 2, right? Those are the possibilities to modify A. Same way, the modifications possible for B are 0, adding 1 and adding 2. And same way, possibilities of modifying C are again adding 0, again adding 1 and again adding 2. But if we think about, like, ideally we can go and try all these options, but if we carefully think, if we have decided that A will be added 0, B will be added 0, and then we have to make their triplet sum to be divisible by 3, won't it already cover what has to be added to C? Because if A is fixed to be adding 0, B is fixed to be adding 0, then of course C has to be modified. So eventually we don't have to worry about these possibilities if we fix A and B. Let's explore and see like what we are talking about. Let's first decide that in A, in the first item, we are adding 0. In second item, we are adding 0. If this is the decision we have made, if we have fixed first two values, then the array will look like something like this. We will leave it 10, we'll leave it 12. Third value is 15. Now think about 10 plus 12 plus 15. That is already divisible by 3 or not. So 15 plus 10 will be 25. 25 plus 12 will be 37. 37 is not divisible by 3. So in that case, what we will do, we'll have to add 2 and make sure that 15 becomes 17. Okay, so we have added 2 here. Keep this in mind. Now, next, if you take the next number, which is 16, now add 16 to 12 and 17. So 12 and 17 are 29. 29 plus 16 is 45. So if you say this is divisible by 3, so what we do is let's not add anything to 16. It is a plus 0 here. Then let's take another 17 in. 17 plus 17 is 34. 34 and 16 is 50. In 50, what do we add to make it divisible by 3? Let's add 1 to the next number. So let's make 17 as 18, which is by adding 1, and then move forward. Okay, after this, 200 comes in. Now 200 plus 18 plus 34, because the sum of their digits is divisible by 3, then we don't have to add anything. It's a simple divisibility check that any multiples of 3 have. So 200 does not have anything to be added. Next we get is 132. 132 plus 18 will be 150. 150 and 200 will be 350. 538, this is not divisible by 3. We will have to add 1 to it. So in this process where we fixed, just remember here we fixed 0 to be added here, 0 to be added here. In this total thing that we have to add is 4. Okay, now we will try other possibilities also. Let's loop over the once again. Let's go over the array once again and decide what if we did not fix initial two values to be adding 0 and 0. Let's say now we are thinking initial two values that are there, which are 10 and 12. Let me write these two. Let's say we fix them and we said, here we decided to add a 0, but here we decided to add a 1. If that was the case, then we are deciding to make it 13. Okay. Now let's take the next number in. Next number is 15. 15 and 13 is 28. 28 and 10 is 28 and 10 is 39. Okay, did I miss anything? 13, 10, 23. 23 and 15 is 38. Yeah, it is 38. So if we decide to add 0 here, 1 here, then of course the next number that we are taking in, there 1 has to be added. So in 15, we add 1 and make it 16. So just remember we are adding 1 to make first 3 to be divisible by 3. Now, same way, after 15, we have next number as 16. If we take 16, 16, 16 will be 32, 32 and 13 will be 45. So that 16 does not require anything to be added. Let's take the next 17. So 16, 16, 32, 32 and 17 makes it 49. 49 is not divisible by 3, so we decide to add 2 to it And when we decide to add 2 to it, so 17 has to become 19, which is giving us a +2 factor. Then you get 200 in. 200 plus 16 plus 19 will make it 235. 538 to 10. We have to make it 12, so we'll have to add 2. If we add 2 here, it will be 202. Same way, let's take 132. 132 plus 202 plus 19. 3, 5, and 2, 1, 3. It is 353, 3, 3, 6, 5, 11. 11 is not divisible by, so we'll have to add 1. So let's add 1 to it, it becomes 133. Now, if we go with this area, if we go with this approach, then it will eventually require 2 plus 1, 3, 2, 5, 1, 6. This will require modification of 6. So far, our best answer is 4. Okay, we will repeat this process. Here we added 0, 0, here we added 0, 1, here we will add 0, 2. That will be first 3 choices. Then we will be adding 1 and 0. Then we will be adding 1 and 1. Then we will be adding 1 and 2. That will be another 3 choices. And then last we will add is 2 and 0, 2 and 1, and 2 and 2. Those will be only possibilities. So this gives us 3 possibilities. This gives us another 3. This gives us another 3. So if we repeat this process 9 times, and out of all of them, whatever are the minimum answers that we get, that will be the final answer. So if we go with this strategy, we will have a 9n approach, because we are looping over the array 9 times. Ideally, we could have gone with 3 values here also. That would have given us a time complexity of 27n. But if you see, 27n is not required because first 2 modifications are going to impact third one anyways. So whatever modifications we are going, yeah. So you just need to go ahead and implement this and upsolve this question. I hope this clarifies the point how we could have utilized this observation and solve this problem. Okay, so wish you happy coding. We'll be ending it here.